So we are going to look into these covalent compounds. Okay, covalent compounds. Okay, we have. Okay, I have mentioned to you it's a bonding. Okay, where it involves sharing of electrons between two elements. To be exact, okay, sharing of electrons between non-metals and non-metals. Okay, so non-metal element and non-metal element. So this is going to be sharing. The very important concept that I have taught you is, okay, in order to share, you must be ready to also allow other people to share. Okay, if you want to gain one electron or you want to share one electron, you must stand by with one electron to let other people to maybe share the electron from you. Okay, like for example, if you have hydrogen, okay, hydrogen, okay, they have, okay, only one valence electron, and they need only one more electron to reach, okay, what we call as, okay, hydrogen is one. Okay, so if I draw for hydrogen, okay, hydrogen has one electron, another hydrogen has, okay, another one more electron. Okay, hydrogen, because the first shell can only support up to 2 electrons. Okay, we call it not octet. Yeah, okay, octet is 8 electrons. If it is going to be 2, we call it duplet. Okay, so they are going to only require one more electron. Okay, so what happens? Okay, they are going to overlap, and then hydrogen, in order to share, okay, in order to share, hydrogen must put forward its own electron to be shared by the others, and this hydrogen will put forward another one more electron, okay, from itself to be shared by the another hydrogen atom. So therefore, this is going to be achieved, hydrogen H2. Okay, this is a covalent bond, single covalent bond. Okay, where only one pair of electron is being shared over here. And then you can look at the structure. Okay, the hydrogen atom has reached, okay, a duplex structure. Okay, but this is only for hydrogen. For most elements, they will reach what we call as octet structure. Octet structure means, okay, they are going to reach 8 electrons, or we call it as noble gas configuration. Okay, noble gas configuration means something like group 8. Group 8 is going to be noble gas, and the valence electron is going to be 8. So we want to reach noble gas electron configuration. Okay, so this one is just an introduction. So now, okay, since we have already learned about yesterday, I taught you about, okay, the single covalent bond. And I show you the single covalent bond between chlorine gas, okay, Cl and Cl. I also showed the double covalent bond, okay, between oxygen and oxygen, O2, oxygen gas. And I have also showed you the triple covalent bond between nitrogen and nitrogen, N2. Okay, and now we are going to go and explore further about this, about covalent compounds. Okay, so we have many examples here. Okay, we are going to actually start to actually draw, okay, the dot and cross diagram. Dot and cross diagram basically, okay, it shows the valence electron. Okay, it shows the valence electron. So I'll try to actually draw nicely for you here, okay, for the hydrogen chloride. So hydrogen chloride, okay, this is hydrogen. Chloride is going to be Cl. Okay, chloride is the ions of Cl. Okay, you have Cl, HCl. So hydrogen, okay, we know that hydrogen is going to be H1. Cl is going to be 17. So 2, 8, 7. Okay, 7 valence electron. You can get this from your periodic table. So now, if I want to draw the hydrogen, okay, hydrogen have 1 valence electron. Cl has 7 valence electron. So 1, 2, 3, 4, 5, 6, 7. So now, In order to be complete, hydrogen needs to achieve what structure? Of duplex structure. Good. Okay. And in order to be complete, Cl has to achieve octet structure. They require one, hydrogen require one. In order to require one, you need to put forward, okay, the one that you want to share. So now, if you overlap them, hydrogen, I overlap with Cl. This is hydrogen, this is Cl. Hydrogen will put forward one electron. Cl will put forward one electron. The rest of it, 1, 2, 3, 4, 5, 6, the rest 6 electron will remain not being shared. So this is the cross dot diagram for HCl, okay, hydrogen chloride. So this is going to be what we want you to learn how to draw. Hydrogen chloride, done. Okay, let's try another one, which is going to be ammonia. Okay, what is ammonia? Ammonia is different than ammonium. Ammonium is ion, ammonium ion, NH4+. Okay, so ammonia, yeah, ammonia is a pungent smelling gas, okay, which will turn, okay, the red litmus paper into blue. Okay, so the ammonia gas is written as NH3. You won't get this in periodic table. You have to memorize. Over time, you will learn. Yeah, ammonia NH3, hydrogen chloride HCl, okay, or hydrochloric acid HCl. Okay, so ammonia is NH3. Nitrogen. If you look at your periodic table, nitrogen is 7 and hydrogen is 1. So 2, 5. Okay, nitrogen have 5 valence electron. So I'll just draw first for nitrogen. Okay, nitrogen have 5 valence electrons. So 1, 2, 3, 4, 5. Hydrogen has only 1. Now for hydrogen, the constant is they just need 1 electron, okay, to reach duplex structure. But nitrogen, on the other hand, they are having bigger problem. It's like they owe money a lot to other people, but they need to actually go and ask the friend to help. Okay, maybe owe another one, 3 people. Okay, a lot of money. Let's say maybe 3 juta. Okay, owe other people for 3 juta. And each of the friend, he has 3 friends or 4 friends. Each of them can give you only 1 juta, for example. So 1 juta is not going to be enough. At least, okay, he needs to look for another 3 people so that each of them can give you 1 juta, so that you get 3 juta. So in this case, hydrogen is only going to help, okay, to give 1 electron there to share, not enough. So nitrogen, they need 3 to reach octet. So they need to go and look for another hydrogen and another hydrogen. Okay, they need to look for it. But this is got nothing to do with transfer of electron. This is going to be sharing. So in order to share, they need to put forward. Hydrogen need to put forward 1 electron. So for this hydrogen, nitrogen will put forward 1 electron only. For each of them, they will put forward 1 electron. So let's have a look at how they will look like. Okay, so nitrogen, okay, overlap with 1, overlap with another 1, overlap with another 1 hydrogen. This is overlapping. And hydrogen will put forward its own electron. So 1, 1, 1. Nitrogen, okay, because they are sharing with this 1 hydrogen, they will put forward 1. they will put forward this over here. They will put forward for this, and left with 1 and 2 electron. Okay, so these 2 electron, okay, will stay here. So this is what we call as, if you look over here, this is what we call as bonding pair of electron. Okay, bonding pair of electron. Bonding pair of electron. The electron that is not being paired, okay, we call it as lone pair. Okay, but this one is not so important. Okay, but if you know, want to know, this is called bonding pair of electron. Okay, bonding pair of electron. This is called lone pair of electron. Okay, because they are alone. Yeah, lone pair. So that is going to be the structure for ammonia. Okay, the cross dot diagram for ammonia. Okay, the cross dot diagram for ammonia. Let's have a look at the cross dot diagram for, let's say we try to look at methane. Okay, now methane, okay, is going to be, normally this is not so popular. Okay, they will give you the formula if you are not sure. They will give you CH4. Okay, no need to worry. Do I need to memorize so many? No need to worry so much about it. Okay, if something that is not so common, they will give you. Okay, ammonia is common. Okay, please start to learn about ammonia, NH3. Okay, so methane. Yeah? Ammonium ion. Okay, NH4 is ammonium ion. Ammonium ion then is going to be NH4 plus. Okay, ammonia is NH3. Okay, now methane. Okay, methane is CH4. Carbon, okay, is going to be 6, 2, 4, 4 valence electron. Hydrogen is going to be 1, so 1 valence electron. So if I draw for carbon here, carbon, okay, they have 4 valence electron. Hydrogen, only 1 valence electron. Hydrogen, the concern of hydrogen is to try to get 1 more electron. The concern of carbon is to try to get 4 electrons. They need to share 4 electrons. Hydrogen, no problem, I go and attach, okay, I can share. Hydrogen, the problem solved. But for carbon, the problem is not solved. Okay, because I am going to get, okay, 1 electron from the hydrogen. But it's not enough. I need to get 4. Carbon needs to get 4 more to get 8. So you will need 4 atoms of hydrogen. Okay, so how do I draw 4 atoms of hydrogen? Now you need to determine, okay, which one will go in the middle, which one will go surrounding. Of course, the one that is going to be sharing with many things will be in the middle. Yeah, so carbon, okay, carbon is going to be at the middle, so I'll draw, and then there should be 4 hydrogen, so I just draw 1, 2, 3, and 4. Hydrogen, 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 hydrogen. Hydrogen will put forward 1 electron here, 1 electron here, 1 electron here, 1 electron here. And carbon, for each of them, okay, carbon will put forward this one. So carbon will put forward this. That. Carbon will put forward this. Will put forward this. So you can see that all of their electrons all become bonding pairs. Okay, there are 4 bonding pairs. There is no lone pair over here because carbon now will have total of 1, 2, 3, 4, 5, 6, 7, 8. Octet structure has been reached. Hydrogen has duplet structure. They have reached duplet structure. Okay, they are both happy. Yeah. So that's methane. Let's have a look at water, something common. Okay, now maybe you need to start to think water in a different way. Okay, water. Everyone knows water is H2O. Okay, but H2O, okay, the compound that we drink every day, okay, is a covalent compound. Okay, it's a covalent compound. The salt that we put for food and we eat every day, okay, is called table salt. That is going to be sodium chloride, NaCl. Okay, everything in chemistry, okay, the ionic compound we call it salt, but not everything you can eat. Okay, NaCl is called table salt, which is going to be can be used to be eaten, but don't go and eat the NaCl in the lab. Yeah, so that is a common salt. Okay, so that is an ionic compound. Okay, so everything that we use in our life is actually related to chemistry. Okay, now coming back to here, okay, water is a covalent compound. How do I know hydrogen? Okay, it's non-metal, oxygen is non-metal. Yeah, so here, okay, I know that hydrogen is 1, oxygen, if I look at my periodic table, I have, okay, 8. So it will come under group 6, yeah, so 2, 6. 6 valence electron. So if I draw, hydrogen is going to be 1. Oxygen, okay, don't worry when to actually use the dot, when to use the X. You can just change it. Yeah, as long one is X, another one is dot. Yeah. So here oxygen, there are 6. So 1, 2, 3, 4, 5, 6. Now the constant of hydrogen, okay, is similar like what you have experienced earlier. They just need 1. Then they are settled. Okay, but the problem is going to be for oxygen. Oxygen, they cannot settle for 1. They need 2 to make it to 8 or octet structure. This can only supply 1. So not enough. Imagine oxygen, they require 200,000 and you are only able to provide 100,000. You need to go and look for another one. Yeah, another one more friend that can give you 100,000. That is going to be another hydrogen. Okay, so you are going to have, okay, oxygen. Okay, if I put the oxygen here, I'll just put oxygen here, and then overlap 1 and another one. Okay, overlap. So you have hydrogen, you have hydrogen. So now hydrogen will put forward the electron and oxygen have to also put forward the electron. So oxygen will put forward this electron, so 1 is taken. Will put forward this electron, this one is also taken. But you will notice that there are 4 electrons, okay, there. So the 4 electrons will come over here. Okay, so Brian, these 4 electrons are known as what pair of electrons? Lone pair. Okay, so it has, okay, water has 2 bonding pair of electron, 1 bonding pair, another bonding pair, 2 bonding pair of electron, and it has 2 lone pair, 1 and 2 lone pair of electrons. Okay, that is going to be the structure for water. Okay, now let's move on to maybe something more. Okay, let's look at methanol. Okay, methanol is not something common also. They will give you, okay, the formula. The formula is CH3, okay, OH. This is the formula. Okay, CH3OH. And if I want to draw this, okay, it's also important, okay, to know. I think it's also good if you know about this. Yeah, if you have like this, okay, this can be represented by carbon represented by this. we write it like this. Okay, CH4. Okay, and then if you have HCl, we write it as HCl like this. Ammonia, we write it as NH3, so we write it like this. Water, we write it like this. Okay, you get the idea. Now, for carbon, it is important to look at carbon will always have 4 bonds or 4 hands. Okay, you can look at it in that way. Carbon will always have 4 hands. Okay, now if I have methanol, it's easier if you look at it in that way. This is carbon. Okay, carbon has how many hands? 4 hands. You draw the 4 hands first. 1, 2, 3, 4. Okay, you draw the 4 hands. There are 3 atoms of hydrogen. You put the hydrogen. You put first. Okay? And then there is OH. You put the O, and this O is bonded to not to carbon here, it's bonded to hydrogen. So bonded to hydrogen. You write this first because this will help you in drawing. Okay? Now, how to proceed from here? Carbon, it has 4 electrons. Okay? And 4 hands. You see here, 4 hands, it means 4 things will be surrounding. Okay? So what I will do, I put carbon, I put a circle. 4 hands. I put 4 things surrounding carbon first. Okay? This is basically to show carbon is having the 4 hands. Okay? Hydrogen, I put hydrogen. Hydrogen will give you 1. Okay? This hydrogen will give you 1. This is hydrogen will give you 1. Okay? Carbon, on the other hand, carbon is always going to have, okay? Carbon is going to be, you see, 4 valence electron. Okay, carbon will have 1, 2, 3, 4. Okay, 4 valence electron. Now, you need, if you are sharing with the hydrogen, you need to bring forward as well. These 3 will go here. I hope until this you are clear. Okay? There is 1 more electron. And this 1 electron, okay, is going to be shared with here. Okay, with the O. Okay? So I put, okay, X. Okay? And then there is O. Okay, there's O. Now, if I share someone 1 electron, oxygen will share how many electrons? 1 also. Okay, if I give 1, another 1 will give you another 1. Okay, now, okay, I am going to show, okay, the electron from the oxygen, I am going to change the shape a little bit. I am going to actually say the electrons is O like this. Is that clear? This is coming from the oxygen. Now, oxygen is 8, yeah, so 2, 6. Oxygen has 6 electrons, so 1, 2, 3, 4, 5, 6. Okay, 1 of the electron is already come over here. You agree? 1 electron already came here. So there are 5 more electrons hanging around. Okay, and hydrogen, you see hydrogen is sharing with oxygen. So I put another hydrogen here. The concern of hydrogen is they want 1 electron. Okay, they have, okay, let's say I'm just still using the hydrogen, the dot here. So hydrogen, okay, and then oxygen is putting forward another dot. Okay, for hydrogen is already settled. So easy, oxygen put another electron over there. Now from here what you can see is there are 1, 2, 3, and 4. 4 electrons that is not bonded. So 1, 2, 3, 4. Not bonded. This is methanol. Okay, maybe a little bit complex, yeah. So, but however, this is how it looks. Okay, and let's have a look at the last one. Okay, not last one. I actually wanted to show the ethene as well. Okay, but ethene can wait. Yeah, no need to actually show now. Yeah. Carbon dioxide. Let's actually look at how do we have carbon dioxide. Carbon dioxide means there's 2 oxygen. Carbon 4 valence electron. Okay, 1, 2, 3, 4. Oxygen. Oxygen is 8, 2, 6. Okay, so oxygen has 6 electrons. Now for oxygen, they need 2. Okay, they need 2. But for carbon, 2 is not enough. Okay, carbon needs 4. So carbon needs another 1 more oxygen actually. Okay. Now, if I have carbon, I join with oxygen. Okay. Oxygen requires 2 electrons to reach the octet structure. So therefore, oxygen needs to also put forward the 2 electrons. So oxygen will put forward 2 electrons. Oxygen will put forward 2 electrons. Carbon will put forward also 2 electrons. 2 electrons. 2 electrons. Look at carbon. They put forward 2 electrons. Another 2 electrons this side. There's nothing more to put forward here. 0 here. Yeah. But oxygen, they only put forward 2 electrons. Each of them have 4 electrons left. So 1, 2, 3, 4. 1, 2, 3, 4. So this is also can be written like this. Number 1. Carbon dioxide. Okay, I hope this is clear. Okay, maybe the difficult part is the over here. Okay, but however, all this example is taken from your textbook. You can just open your textbook and just go through this again. Yeah, and the video is recorded. You can also watch it again. Yeah, thank you everyone.